In the development of this project, I was helped by PCBWay, which is one of the most experienced PCB manufacturing companies in China in field of PCB prototype and fabrication. If you want to make your own PCB for this project or for any other electronic project, PCBWay is a great choice. They have a large online community where you can find the open source project, and you can also share your project there. From my personal experience, I can tell you that on this community you can find many useful projects with already designed PCBs from where you can place an order directly. To make an order for our custom PCB, we need to click on Quote Now. On the right side you can see the place for ordering the PCBs for selected parameters. And on the left there are additional options to tweak for your PCBs. So if you want your PCB, just type PCBWay.com on your browser.
Hello, Royal Raymond Rife was a scientist, inventor and medical researcher. He is known for his microscope, which he claimed could observe live microorganisms, but also by an electronic device constructed by him called the Rife Machine, which according to his claims is capable of curing very serious and incurable diseases. In order to not repeat myself, if you are interested in the method of operation, making, technical characteristics, the way it is claimed to heal and many other information regarding to the Rife Machine, I recommend you to watch my previous video related to this topic. There you can also read my personal opinion regarding the technical functionality, but also the claims in the medical terms, at least as far as I can conclude. Also, I describe a very simple way to make such a machine yourself if you have basic knowledge in the field of electronics. Despite its simplicity, the disadvantage of this machine was the fact that the frequency of the carrier signal was in the range from 50 to 180 kHz. Although many Rife machines are sold on the commercial market not exceed 100 kHz, the original machine made by Rife has a carrier of around 3 GHz. This time I will present you a way to make an advanced Rife machine where the carrier frequency can be changed continuously in the range of a few kilohertz up to 100 megahertz, which far exceeds the range of the original machine. In addition, the precision and stability of the carrier frequency is incomparably higher thanks to the use of the modern microcontrollers. The carrier frequency is displayed on a color TFT display with a beautiful retro style scale. Also, for the source of Rife frequencies, I will present you a wonderful software that is very flexible, simple to set up and graphically excellent. In general, the device consists of several components. A carrier frequency generator, which can generate a signal in the range of up to 100 MHz with great precision and tuning steps, and the frequency is displayed on a color TFT display. Detailed schematics, instructions and code for this generator can be found in one of my previous videos. Next, a Rife frequency generator, which in this case is specialized PC software for this purpose, installed on a laptop computer with a sound card. We will analyze this software later. Next, a modulator that modulates the RF carrier frequency with low frequency Rife signals. It's this little board. An amplifier of this modulated signal, which together with the high voltage transformer drives the plasma tube. And a plasma tube to output the power in the form of radio waves to penetrate the body and deliver the frequency. Now before we see how the device works in reality, let's first briefly explain Frex16 PC software.
Frex16 is a wonderful free program created by Ken Uzel. You can download it from the Spectrotech site, where registration number is provided for free use.
Now I will briefly describe how to use it. So this is the start screen. The application contains a large database with ready-made Rife frequency sequences for various diseases. We can search for the disease according to the initial letter or to the search tab. For example, let's look for Rife frequencies for the treatment of herpes simplex type 5. We need to type herpes in this. So this is herpes simplex type 5. These are given frequencies. Now we set these frequencies to buffer. Then view the buffer and select herpes type 5. Exit. Next we clear the previous buffer. So this is preview buffer, and enter the new one. Here are the frequencies, and here are the durations of each individual frequency. We can change the duration of each frequency. For example, 100 seconds. Or 50 seconds. Another very useful function is that we can assign our own frequency sequence which is not contained in the given database. We do it as follows. We press the edit button and enter the frequencies we know from another source in the fields in order. For example, etc. We can form a sequence of up to 40 frequencies, as we see. Next we need to enter the name of the new program. For example, test. And click save and exit. If you like to find the new program, here's the new entered program with the name test. Now we press the start button and the following screen appear. On the left is the entire therapeutic program as well as its duration. In our case 32.5 minutes. This is the start frequency, the volume slider, and the shape of the output signal. We can choose different shapes of the signal, sinus wave, next square wave, triangle wave, sawtooth positive, sawtooth negative. It have also white noise generator. In practice, rectangular and sawtooth negative shapes are mostly used. In this section is visually presented the shape of the signal that is currently being generated. The program starts when you click on the run button. As time passes, the elapsed frequencies turn red, pardon. And the end of the set time, the generator is automatically switched off. In our case, after 31.92 minutes. Here we can choose another frequency, for example. In this case, this is the carrier signal with the harmonics and the amplitudes. So carrier and harmonics. Now, first we turn on the generator and tune the carrier frequency. I will set carrier frequency to 3.9 Megahertz. Then we turn on the Rife machine. The left potentiometer regulates the degree of modulation, that is the power, and the right amplitude of the carrier. Now by starting the Frex software, the device starts to radiate. In the software we can choose the shape of the Rife signal, which is mostly rectangular, and we can also experiment with other shapes and options. Each frequency defined previously is emitted for a precisely defined period of time, after which the field with the current frequency turns red. We can monitor the frequency of the device in a simple way with a portable radio by matching the frequency of the radio to that of the carrier. This is small shortwave radio. We need to match the frequency 3.9 Megahertz. The right frequency generated by the laptop should be heard on the radio. Next, we will perform a spectral analysis of the emitted signal using a software-defined radio with the accompanying software, so that this time we will be able to visually observe the output signal in the frequency domain. We can receive the signal through this small antenna, which means that the same signal also passes through our body. Let's look at the carrier signal first. This is the carrier signal, and when we change carrier signal at the oscillator, as we see, also change the spectrogram. Currently, it has a frequency of 3.930 Megahertz, and we can continuously change it. For example, 3.964. In the original Rife machine, this frequency ranged from 1 to 4 MHz. In our case, we can experiment with the carrier frequencies from 0.1 to 100 GHz. This is example with 7.3 MHz carrier. .8 megahertz, 15.3 megahertz, 0.1 megahertz carrier. Next, we will perform a spectral analysis of the emitted signal using a software-defined radio with the accompanying software, so that this time we will be able to visually observe the output signal in the frequency domain. We can receive the signal through this small antenna, which means that the same signal also passes through our body. Let's look at the carrier signal first. This is the carrier signal, and when we change carrier signal at the oscillator, as we see, also change the spectrogram. Currently, it has a frequency of 3.930 megahertz, and we can continuously change it. For example, 3.964. In the original Rife machine, this frequency ranged from 1 to 4 MHz. In our case, we can experiment with the carrier frequencies from 0.1 to 100 GHz. Now, when we add the Rife signal, the carrier is modulated, and this is seen by changing the spectrogram. Let's try. If at the input instead of a Rife signal we bring a music or speech signal, it modulates the carrier, and the signal has a shape identical to that of a broadcast radio station. And finally, a short conclusion. The device that was presented earlier is in every respect superior to the original plasma Rife machine, mainly thanks to today's level of development of electronics. Besides, it can be made by an average electronics guy such as myself. Can you just imagine what the companies involved in the production of electronic devices for the needs of medicine are capable of producing? If this device really worked according to Rife's claims, or at least close to it, by now modern medicine would surely have used this method of treatment very often. And I'm currently testing a very simple and inexpensive way to make a plasma Rife machine that can be built mostly from parts that can be found in any electronics shop. Would not cost more than $20, and I will post the tutorial with complete schematic diagrams and how to make it in one of my next videos.